let's talk about a few materials that's used in electric circuits and electricity. The first thing we want to talk about is what we want to call is a conductor. Okay. What's a conductor? A conductor is something that, channels the flow of electrons, right? And a conductor is going to be usually metal, right? And that's the first type. So then what we want to focus on is the second part. Well, let's skip number 3. Okay, let's go to number 3 here. And number 3 is what you call an insulator. Okay, an insulator is a barrier, right? Anything that's non-conductive of electricity is a barrier, right? And the third thing we want to focus on, well, in the middle is what we call a semiconductor. Okay, so it's clear what a conductor is, and it's clear what an insulator is, right? A wire, the plug, right? It's a conductor. Very simple. You do not want to touch a conductor through electricity. You don't want to do that, right? An insulator, very simple. Like wood is an insulator. It won't conduct. Dirt is an insulator. It won't conduct, right? But a semiconductor is something that focuses on logic, right? These are logic gates. Okay. So a lot of this small voltage application, right? So we talk about, let's say, small voltage application, okay, is considered in a semiconductor logic environment, right? And metal usually is determined for high voltage, right? And not only high voltage, but also, we call it electron transport. Okay? When we transport electrons, we use conductor. So let's look at this a little more closely. Okay? What we're going to focus on is a source, what we call a source voltage. So we focus on a source, and our source is like a battery or a plug, right? And our source is either a voltage source or a current source. Okay? For the most part, we will be focused on voltage sources today. Okay? And its symbol is Vs, like this, or large line, small line, plus minus. The second thing we talk about is a conductor, which we talked about earlier here, metal conductor. But a conductor is a wire, right? And current travels on the wire. Okay? So that is a conductor. Okay? And the third thing we want to talk about, obviously, is a resistor. In a resistor, it consumes electricity, right? So a resistor it could be a barrier, it could be an insulator as a barrier, but for the most part, it's something that consumes electricity, like an appliance, TV, lights, fan, HVAC, right? So here we produce electricity, here we transport electricity, and here we consume electricity, okay? In this fashion, we will have a basic circuit that looks like this. We draw the circuit, plus minus Vs, and we draw a square, and we draw an R for a resistor here. And what happens, you have a voltage, and you have a resistance. You have a source, and you have a consumption. And here the I is what the wire transports. I is your current. This is nothing but a current. So voltage, Vs, has units of volts, or V. Resistor have units of ohms, or omega, which is a Greek sign. It's an upside down horseshoe. But please don't go to a job interview and say the unit for a resistor is an upside down horseshoe. It's omega. Okay? And current I has units of amperage, A. So our equation is V equals IR. This is the equation we're going to focus on throughout the entire semester. Okay? Now,